Hey folks, we are moving on to 2.8, which is again inequalities, right, and sign charts. And this is sort of the part 2, right? When we did it the first time I called it part 1, and this time I'm calling it part 2 because that's sort of how things flow. It's like the sequel. And as we're working through this, I want you thinking about what are the key values and how are we going to come up with them, because they're a little bit different than they were last time. So, lost my train of thought. So the key values that we're going to be looking at, they are going to come from a couple different places. Before, if we had a polynomial that looks something like this, oh, that's not what I wanted to have happen. Right, if I had something like this, then our key values came from each of the parentheses, right? Either x plus 5 equaled 0, and x equaled -5, or x plus 7 equaled 0, x equaled -7. That's how we got the key values previously. Now I know it's an inequality, so it feels a little bit different, but that's how I got the key values. And I think that's one thing just to clarify is that a lot of you say x lies, but don't always know what it means. The idea that x lies is just a phrase that describes what we're doing here in order to solve. And so it's not that x lies, it's that in order to solve for x, I have to do the inverse operation. Okay, so if I go over here, what are the key values of, let's say, this rational inequality? I'm going to move my 5 and my 7, and then I'm going to put it over, I'm just going to say x minus 3. And I'll keep it greater than 0. The inequality doesn't really matter. But yes, -5 would be a key x value. And yes, -7 would be a key x value. But so is 3. Right? Because we want to identify key x values from the numerator and key x values from the denominator. And the key x values from the numerator, so key x's, the key x's in the numerator make our function equal to 0. And the key x values in the denominator, that's where, whoops, that's my phone falling. That's where our function is undefined, right? So we need all of them, but they have different roles and responsibilities. And so when we are identifying key values, we need to be aware of the fact that like they all matter, but they mean different things. Okay, so I want to run through an example. And last time we did a sign chart example, I think we sort of did it 2-column notes where we like added information to the side. I love 2-column notes, but I also realize that for some of you, it's just not your preferred method. The reason I like it is it keeps everything nice and organized, right? And it shows you work and then steps. And then ideally you've written steps, and I've gotten a little bit more lazy with my steps because I think it's important that you come up with steps that you need. But we write our steps so that we can reproduce those, right? That's been a big thing that we've been talking through lately. Anyway, I've got x squared plus 2x minus 3 over x plus 1. And I want to know, where is that greater than or equal to 0? Okay, so just really quickly, greater than 0, those numbers are positive. Equal to 0 means we can equal 0. But first thing we need to do is we need to get our key x values. And the way we're going to find those is by factoring. So I'm going to factor the numerator. My stylus has like a weird lag today, so hopefully you're able to make out what this is saying. But I'm factoring the numerator, right? I'm looking for what multiplies to -3 and adds to 2. So multiplying to 3, adding to 2. So if you are not getting what's factored the way it's factored here, then my guess is you have those backwards in your brain. But remember, 3 times -1 would be 3. 3 plus -1 would be the +2 in the middle. So my first step is to factor. which means my key x values, right, my key x's, oh my goodness, key x's are -3, +1, and -1. So if I draw my sign chart with those key x's in there, right, always working sign chart, same as a number line, where the lowest numbers are on the left. This would be -infinity out here. This would be +infinity. I don't know that we need that, but you got it. So the key x's are -3, +1, and -1. Now -1 came from the denominator, and so we are undefined right there. At -3 and 1, we are equal to 0 because we're in the numerator. And we said key x's that come from the numerator are zeros. Now, a cool thing we can do that we haven't done yet is we can think about what this means in terms of like graphing it. And we could say, okay, it's 0, so I'm going to fill in the circle here. And it's 0, so I'm going to fill in the circle here, but then an open circle right here because of the undefinedness. If you want to draw that in like that, you can. Okay, so after we factored and get our key x's, now we have to run our tests. So we're going to test, I'm going to just do -10. And I'm going to get a negative on top, another negative on top, and a negative on the bottom. And that's going to equal a positive on top divided by a negative on the bottom, which will be a negative overall. Right? If you've got 2-column notes set up here, maybe one of the notes you're going to add is that negative times negative is positive. Negative divided by negative is positive. But negatives have to occur in a pair to turn positive. And so if that, like the case we had right here, the reason that turned back negative is because we had a positive and a negative together. There wasn't a second negative to sort of cancel it out or to turn it back positive. Anyway, back to our second round. Between -3 and 1, I'm probably just going to test -2. Except for because of spacing, I am going to move my test way down here. I'm going to test -2. And when I test -2, -2 plus 3 is positive in the numerator. -2 minus 1 is negative. -2 plus 1 is still negative. So I got a lot of negatives. A negative on top, negative on the bottom. That is a positive result for that stretch of sign chart. Okay, back in the middle, we're going to test 0. 0 plus 3 is positive. 0 minus 1 is negative. 0 plus 1 is back positive. This is a negative stretch. And then the very last part, shorten it up even more, test 10. And I'm going to get positive, 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 positive. Okay, and so since it's all positive there, I can just put positive. Okay, so now my job is to look at what are the places we are greater than or equal to 0. So greater than or equal to 0 is where we're positive. And we are positive from 0 to -1. But -1 is an open circle because of the undefined part, so I'm just going to use a parenthesis. And we are positive from +1 to infinity. So I'm just reading along the sign chart, looking for places where we are positive and 0. Right? If we couldn't include the 0, then we would change our brackets to parentheses, but because we can include 0, because of the equal to part, then we are using the zeros. Then we are using the spots where it was 0. We've got those filled in circles, and so on and so forth. Okay? That's what's happening here. I'm going to give you the opportunity to practice. We'll practice this lots. You'll be great.